Good evening, everyone. This is Renato Jr. Langkorararugal, and tonight I'll be presenting to you the topic that I have chosen and reviewed, and this study is all about the hepatitis B virus infection using chi-square statistics. And this studied by Oluwal A. Odetunmibi, Adebowal O. Adejumo, and Timothy A. Anake. And I will also present to you what is a chi-square statistics, how is this used, and how to interpret the result done by this statistics. So let's go. Just to give you an outline for this study, again, I'll be dividing it into two, the chi-square test for independence. I will try to elaborate this more. What is a chi-square test for independence, how to calculate the chi-square test for independence, and how to interpret the result done by the chi-square test for independence. And the latter part, I will also try to cover about the study that I have chosen, their methodology, the result, and the conclusion. I didn't also put the recommendation, but I will also give that to you. Before going to the understanding of what is a chi-square test for independence, I have a research problem that I just made to help us understand what is a chi-square test for independence. Also, the data is a self-made. So let's try to go in. Teacher Nuts wanted to investigate if gender and preferred snacks were independent in passing board exam of professional teacher. This means he wanted to find out if a person's gender influenced their preferred snacks or their snacks choice. He conducted a survey and he organized his data in the following table. So this is the table. Again, this is a self-made. Okay. So let's just say male. We have 64 who chose chocolate, and another group of male who chose, which is 78 group of males that chose bubble gums. So the total of our males that participated in this survey is, in this study, is 142. With a female, we have 58 who chose chocolate, and we have 40 who chose bubble gums. And the total is 98 female participants. And the total of chocolates that chose this kind of prepared snacks is 122, and with the bubble gum 118. So the research question that can be derived from this sample of research problem is, do the values of one categorical variable depend on the other categorical variables? What is a chi-square test for independence? From the previous one, we learned that the chi-square test is used to measure if experimental data supports a particular hypothesis. And just to let you know, a chi-square test can be used in different ways. It's either, like the previous one, goodness for fit, or how well the experimental data fit or supports the hypothesis. But with mine, the chi-square test is used for finding the independence. So when you say chi-square test for independence, this is a statistical hypothesis test used to determine whether two categorical or nominal variables are likely to be related or not. Or answering the question, do the values of one categorical variable depend on the value of other categorical variables? That's why the chi-square test for independence, also known as a chi-square test of association, finding if there is an association if there is an influence. So let's do the first step. That is, write the null and alternative hypothesis. So from the one that I have made, the research problem, my null hypothesis is gender and preferred snacks are independent. So what I'm trying to say, there is no association. I think there is no influence in passing the board exam. And my alternative hypothesis, gender and preferred snacks are not independent. That means there is an association, there is influence of passing the board exam. Second step, calculate the x-squared or chi-square test statistics. And to be able to do that, first you must have a table from the collected data, and that will become your observed data. Second, you should be able to make an expected value table from the totals. And to do that, we have a formula. Our formula is the expected value is equal to the row total times the column total divided by the overall total. So with that, we have like for example, our total rows per male is 142, and we will multiply it with the 122 with the chocolate. So 142 times 122 divided by 240 as our overall totals, then you will get 72.2 as your expected data for male. So continue that until you computed all the expected data. Third, you check. Make sure each number in the expected value is higher than 5 or is 5. And as to our table, we have 72.2 and nothing there is lower than 5. So this is correct. D, you calculate now the chi-square x-squared value, and we have the formula for that. So x squared is equal to the sum total of closed and open parentheses observed, and getting the differences of observed minus expected data, and divided by expected data, and do the squared. So get the formula, follow it. Like for example, in our table, we have 64 males who chose chocolate as our observed data to be minus by our expected data, which is 72.2. So do the multiply it by itself and divided it by, again, expected data, which is also 72.2. So, and if you continue that, you should be able to get 0.9313. So continue the process until you get all the data, and don't forget to sum it up, and your chi-square value should be 5.0959 if you use this example, especially the table example. The third step is to calculate the degrees of freedom, and to do that, you get the number of rows and minus it with 1 times number of columns minus 1. And with my table, I just have 2 columns and 2 rows. So 2 minus 1, 1, 2 minus 1, 1, and 1 times 1 is 1. Now, since we have already the degree of freedom, which is 1, and we also have the chi-squared statistic value, which is 5.59. Now, the next step is finding and comparing the critical value level to your x-squared or chi-squared test statistic value. And to be able to do that, you should look up first the degree freedom and the significance level or alpha that you wish to use. Just to give you an idea, in statistics, the default critical value as your significance level to be used is always 5%, which is an alpha that has 0.050. So moving forward, when you try to find what is your critical value, you go first to use the chi-square distribution table. Look first for your degrees of freedom. So in our example, we have 1, and look for the desired significance level that you want to use, which is here in our example 0.05. So our critical value is 3.841. Now if you have already the critical value and also chi-squared statistic value, you compare it. So there should be greater, or should it be less than. So in our case, our chi-squared statistic value is greater than to our critical value. So when you say less than, that means you will not reject the null hypothesis. But if your chi-squared statistic value is greater than the critical value, then reject the null hypothesis. And we're almost done. So to affirm what we have discovered to our example, you go back to our null hypothesis and our alternative hypothesis, and the previous slide showed to us that our chi-squared statistic value is greater than our critical value, and it says there, if that is greater, then you should reject the null hypothesis. So we will reject our null hypothesis here, which is the gender and preferred snacks are independent. So this is rejected. That means no association. There's no relation. And we will use our alternative hypothesis, which is gender and preferred snacks are not independent. So that means there is an influence, there is an association of using in relation to gender and the preferred snacks in passing the board exam for professional teachers. So let's see that in the topic review that I have chosen to the study of hepatitis B virus infection using the chi-square statistic. This study is all about the hepatitis B, which is caused by the hepatitis B virus, HBV, and it affects livers. It has been established that the disease is a serious medical condition caused by an overpowering immune response to infection. To this effect, there is a need for the cross-examination of records of patients on this disease to ascertain the factors that could be responsible for the survival or dying from this disease. So with that, in the article that I have studied, they investigated the independence of age and gender on the spread of the HBV disease through the chi-square test statistics, and the data were secondary collected from the Human Virology Department of Nigeria Institute of Medical Research, or the NIMR, from Yaba, Lagos State, Nigeria, and it contains those patients who were tested positive from January 2006 to December 2015, and also there it stated their date when they were tested, the age of the patient, and sex of the patients also recorded there. After careful analysis of the study through the use of SPPS version 23 and Microsoft Excel, the result can be seen in this table. First table is the distribution of patients by age, and if interpret that, it only shows that the age bracket who receive highest frequency are those with the age of 31 to 40 years of age, and they are with a percentage of 43.65%. And to the distribution by gender, the gender that receive highest frequency is with a female, which is having 11,140 um, frequency. So meaning to say, many of the who tested positive are those with the female. With that, the chi-square analysis made the hypothesis. For the null hypothesis, they stated that age and gender of HBP patients are independent, while the alternative hypothesis stated that age and gender of HBP patients are not independent. And they also set up rules for this study that if happens that p-value is less than the cutoff point of 0.05 significance level, they would reject the hypothesis. The last table is Pearson chi-square and likelihood ratio estimation from the table 5. So when you look at the chi-square, the one that was wished to use is 0.001 or the 1%, and the degree of freedom, they use 6, and the asymptotic significance is 0.027, which is less than 2R p-value of 0.05. In conclusion, it was discovered that exactly active age bracket ranges from 31 to 50 years of age, and they were all greatly affected by the disease. Also, the research established the females have higher risk of contracting the disease when compared with male, since 66% of the recorded data were female. And with the use of the chi-square test method, they were able to establish whether age and gender of those who tested positive to the disease are independent or not. And at the end, we discovered, and we also know, that the chi-square test for independence proves that both variables, age and gender, are not independent. It simply means there is an association between the two variables when it comes to the spread of the hepatitis B virus. As part of the review, I put the recommendation, and I recommend that although there were great results, this study should have added more explicit interpretation of the relationships among the statistical tools, mostly to the chi-square test for independence. Also, it should give more details about the table reference before stating the deciding rules. This would give transparent computation and could give strong validity to the result. And for further development, I believe this study it would be an open door for further research such as on the application to clinical, social, and family setting orientation. Thank you so much for listening. I hope you get something. For more information about this study, I will give you the reference. I will give you the link after this presentation.